Okay, this is lesson 10.5 on trigonometry and area. So first of all, the first part of this lesson is going to be addressing regular polygons. Remember that means equiangular and equilateral. And we're going to start with talking about regular triangles and regular hexagons because those two, along with squares, give you special right triangles. So for a regular triangle, an equilateral triangle, first of all, the central angle measure would be 360 divided by 3. So if we cut that 360 into 3 congruent central angles here, then that means that those would be 120. And when you drop the apothem, so remember that that's the segment that goes from the center perpendicular to the midpoint of a side of the triangle, it's going to create a 60-degree angle at the top there. And that means that it's a 30, 60, 90 triangle. Now, more simpler than that, you could actually just do in an equilateral triangle, we know that this angle measures 60 degrees. When you cut that in half, you get 30. And since the apothem is perpendicular, that makes it a 30, 60, 90. Okay, but the central angle kind of always works. It's a little simple way to figure out if you have a special right triangle or not. So remember that on regular polygons, from the center to a vertex is the radius. So in that diagram, we're given the radius is 6 inches. And then, like I said, when you drop the altitude of this triangle, when you drop an altitude to a side of the polygon, that means it's going to create what's called the apothem. So because this is a 30, 60, 90 triangle, that means that we'll be able to use the hypotenuse here is 6. And then when we do 6 divided by 2, that's smaller, 6 divided by 2 would give us the short leg is 3, and then multiply by root 3 to get that side is 3 root 3. Now remember, that's half of the side of the whole entire triangle. So the 6 root 3 here is referring to this whole side here is 6 root 3. So I have an option. It did ask me to find the perimeter. So I'm going to go ahead and do 6 root 3 times 3, and that gives me 18 root 3 inches. And then I could do 1/2 apothem perimeter. Remember that formula. For any regular polygon, the area is 1/2 AP, 1/2 apothem perimeter. Okay, so the first thing that I'm doing here, the first method that I'm using is I'm showing you 1/2 AP. So 1/2 AP means 1/2 the apothem, which was 3, times the perimeter that we found up here, that was 18 root 3. Okay, simplify that down. 18 divided by 2 is 9. 9 times 3 is 27 root 3. Okay, so 27 root 3 is the area of the triangle. Now, another method for regular triangles, it only works if it's a triangle, it only works if it's a regular triangle, is the s squared root 3 over 4. Okay, that's only for regular triangles. So s refers to side, side squared root 3 over 4. Now, you have to be careful when you square. Remember that the square applies to both parts here. So that's 36 times 3 times root 3 over 4. Okay, and then instead of multiplying and then dividing, I went ahead and divided out a 4 from the 30/60 and then the 4 and got 9, which again is 27 root 3. So it should give you the same answer, of course, and it does. Okay, so for that one, the perimeter is 18 root 3 inches and the area is 27 root 3 inches squared. Okay, for the second example here, these were given to be regular polygons. That's a regular hexagon. And with a hexagon here, we're given the radius is 12 meters. That was the radius that was given. Now, the central angle, again, I can do 360 divided by the number of sides is 6 to figure out the central angle measure. So again, if you visualize all of these angles, central angles there, you would create 6 congruent triangles. That central angle measure would be 60 degrees because it takes 6 60-degree angles to give us 360. So when we drop the apothem, that we're thinking about that triangle right there. We drop the apothem, that's going to be this segment. Okay, that's perpendicular. That creates a 30, 60, 90. So notice that it's also a 30, 60, 90, but it's kind of standing the other direction. See how this one is sitting on its long leg and how this one is sitting on its short leg. So we were given the radius is 12. That means the short leg is going to be half of that, which is 6, then multiply by √3, and that's the apothem. Okay, so perimeter, the side length is 12, and that's because 6 times 2 gives us 12. Okay, and then the perimeter will be 72. The area is 1/2 apothem perimeter, 1/2 apothem, okay, 1/2 apothem times perimeter that we found up here is going to give us 216 √3 meters squared. Now, another option is in a hexagon that is irregular, and this only works on a regular hexagon. Okay, this only works on a regular hexagon. A regular hexagon, when you draw on the central angles, you create 6 congruent equilateral triangles. That means that you can do s squared √3/4 and then multiply by 6 to get the area. Okay, so only on a hexagon. If you prefer to do, because sometimes this is easier. Sorry, let me make that better. Sometimes this is easier. So like on this one, we knew the side length was 12. We could just do 12 squared √3/4, figure out the area of one of those triangles, and then multiply by 6 because there's 6 triangles. So S here refers to the side length, this 12, and then you could plug it in that way. So that's just another option. Okay. What is different in this lesson is, and I think I did one of these on the last lesson actually, but you didn't have any homework on it. So I wanted to make sure that this makes sense to you. So this is a regular pentagon. And so for a regular pentagon, we're going to start by figuring out the central angle measure. So the central angle measure is always 360 divided by the number of sides. So 72 degrees. And then we're cutting that in half because, again, we dropped the altitude. So 72 degrees would be that angle measure, drop in the altitude, and drop the apothem, and that'll make that 36. So that angle measures 36 degrees. Now, I'm always going to use A to represent the apothem here, and I'm going to use X to represent this distance, okay? It's actually half of the side. All right, now, that's a right triangle. Okay, what are we given? We're given 16. Now, if I was going to put a variable on that, I would call that R because that's the radius. Okay, the radius is 16. This is not a 30, 60, 90 triangle. That's why we're going to have to use trigonometry. Okay, so we have the 16 is the hypotenuse. We have 36 degrees. We're going to need to find both the apothem and the side length if we do 1/2 AP. So we need the side length in order to be able to do the perimeter. And so the side length is going to be, let's see, X. 9.4 is the X, oops, sorry. 9.4 is X value. So I did the sine of 36 is opposite over hypotenuse, X over 16. Okay, and then I solved that and got 9.4. Now that is just half the side length. So the whole side length here is 18.8. Okay, the perimeter is 18.8 times 5, which is 94 inches. Now to do the area, I'm going to do 1/2 apothem perimeter. So that means I need to find the apothem. So I'm going to do the cosine of 36 is A over 16. So I'm doing cosine of 36 is A over 16. And I'm getting 12.9 for the apothem. Area is 1/2 times the apothem, which is 12.9, times the perimeter, which is 94. So 1/2 apothem perimeter would give me, round to the nearest tenth, 606.3. Now again, I want to make sure you don't do s squared root 3 over 4. Cannot do this for a pentagon because these are not equilateral triangles. Okay, notice that this is 18.8, this is 16, and that'd be 16 because they're both radii. That is not an equilateral triangle. So the equilateral triangle thing you would do with just regular hexagons. If you wanted to do the area of one of these triangles and multiply by 10, that would work. Or find the area of one of those triangles and multiply by 5, that would work. If you wanted to do 1/2 the base times the height and then multiply by 5, that would work perfectly fine. But it is not s squared root 3 over 4 because they're not equilateral triangles. Okay, and then lastly, this is actually a really simple formula. The hardest part of this is remembering that it exists. So sometimes we get so many different formulas going on that we kind of forget to do that this formula exists. So the area of any triangle, this works whether it's a right triangle, not a right triangle, whatever. The area of any triangle is 1/2 the product of two of its side lengths multiplied by the sine of the included angle. So 1/2 times A times B times the sine of C. Okay, or we could do C and A with B. So 1/2 the C times A times the sine of angle B. Okay? Or we could do with the last pair of sides and it would look like that. Okay, so when you see me write down the formula, you'll probably see me write it that way most of the time. 1/2 AB sine C. And just remember that this has to be the included angle between the two sides that you're using. Okay, so for the first one, 1/2 9 times 20 times the sine of 65. Here is 1/2 times 9 times 20 times the sine of 65. You just type it in your calculator, you're done. Okay, I told you to round these to the 10th. That should give you 81.6. Okay, for the second one, we have, oops, 1/2 times 5 times 6, sine of 133. Type in your calculator, 11.0. Now again, I've got a 0.0 there because we're going to the tenths. So 11.0 square inches. Make sure you label those problems. Okay, so on your homework, you're going to have some regular polygon that are triangles, regular hexagons, regular squares. You'll have some that require trig, which would be any regular polygon that's not a square, triangle, or hexagon. And then you'll have the area of a triangle using the side angle side formula. You'll also have Heron's formula. So if you don't remember how Heron's works, make sure you look that up. You're going to have to use Heron's for a couple of those. Okay, Heron's is when you have all the sides, all the side lengths. All right, that's the end of this lesson.